Hello and welcome to this short demonstration video of the ROS2 brickpi3 packages. brickpi3 is a hardware interface from Dexter Industries which connects a Raspberry Pi to the Lego EV3 motors and sensors. The ROS2 brickpi3 system provides two packages, one for controlling the EV3 motors and another for reading the EV3 sensors. I'll be demoing this with the assistance of Charlie, who you can see here. Let's just make this a bit bigger. Charlie the robot. So yes, I'd like to introduce you to Charlie. Charlie is a Lego Technic robot with two EV3 motors. I've currently got set up a compass up here and an ultrasonic distance sensor here. We also have a USB camera attached. His brains is a Raspberry Pi 3, and we have the brickpi3 hardware interface here which connects the Raspberry Pi to the motors and the sensors. The image that you can see here, this is actually coming from my iPad, which I've got set up on the table here. It's broadcasting an HTTPS video stream, and I'm using the ROS2 image publisher package to pick up that image stream and publish it on the image topic, so you can see it in RViz too. Normally everything I'm about to show you, you just have a single launch file and you just launch it, and that would be that. But for the purposes of this demonstration, I'm going to launch the nodes individually, just so that you can see how all the parts fit together. So I think the first thing we'll do is we'll get that USB camera video feed going. So I've got a number of terminals that I've set up already where we're already logged into Charlie the robot. So here's one here, and I have got this command in my history. So yeah, this command here, I'm going to ask Charlie to publish those images. In theory, we can actually see this directly in RViz already as it's published on the network. I haven't got good results with that. I found the images quite jittery, delayed, and generally it was unsatisfactory. So what we're gonna do is we're gonna compress that image stream just to make it more manageable. So I'm gonna ask Charlie to compress the image stream. So there we go. And this terminal here, this one is running on my own workstation, and I am going to arrange for the decompression of that image stream, and we're going to publish that on the topic robot image. So let's get that going. Okay, go back to RViz. I don't know why it does this, but it always seems to cancel the image, so I'm just going to click on that, bring that back. Okay, so let's see if we can pick up that video stream. So it will be an image type of topic, and we have an image topic. It doesn't know what the name of the topic is, so we ought to go here. Let's have a look and see what options there are. Yeah, it was a robot image topic that we wanted, so there we go. Click on that, and yes, so down the bottom here you can see the view from Charlie. I'm just going to swap those around, maybe make that a little bit bigger. So I think the next thing to do would be to demonstrate the range sensors. So let's see if we can get the range. When I say range sensor, I mean the ultrasonic distance sensor here, and get that up. So I've got some more windows here. Let's get this. Let's shrink this down. Don't need that. So this is running on Charlie. We'll start off with the compass node. That should be broadcasting messages. This window on the bottom right hand side, that's running locally on my own workstation. Let's have a look and see what topics we have. And we have a compass bearing topic. So let us see what messages are coming from that compass node. So it's compass bearing. Yes, so it's broadcasting orientation messages. They're in a quaternion format. Let's get the ultrasonic distance sensor up. This I'm saying here in the ROS arguments, I am saying I would like to be using Lego port 2. The ultrasonic distance node is connected to the ultrasonic distance sensor is connected to port 2. So I'm going to tell it that and ask that to kick off, and we will see what we have here. We have an ultrasonic distance topic. Let's have a listen on that topic. Yeah, so this is broadcasting range messages. So this is the distance in meters to the nearest object. It's got a fairly narrow field of view of just sort of a 5 radians. I think this will be clearer when we get this up in RViz. So I think the next thing to do, let's get those images back, is to show the that range sensor here. So let's add, and we're going to find that's a range topic. Okay, and it's not very happy, and it will be because it doesn't know the name of the topic that we want. So let's bring this down, and we want the topic ultrasonic distance. So let's click on that. Yeah, and I'm going to add some axes so we know where we are. Okay. These axes here, they're orientation axes. So the red bar here, that is pointing in the direction of the wall. This wall here, the wall with the radiator on it. The green bar is pointing in the direction of this wall here. With there's an edge of a bookcase here. That's in that direction. Now in this system, Charlie, he doesn't really know where he is. He hasn't got a SLAM system set up, but he does know the orientation. He knows his orientation in within this room. So this won't move around, but he does know his orientation within these axes. So if we look at this here, so this is the grey cone is the information from the ultrasonic distance sensor. The length of the cone indicates expected distance to nearest object, and detected distance to nearest object, and the direction of this cone indicates which way round the robot is facing. And I think this will be clearer once we get some motors up and we drive around. So on that basis, I think the next thing to do would be to actually get these motors running. Okay, so I should have another window for motors. Yep, here we go. So the brickpi3 system, software system, it's got we're using the ROS2 control system for this. So there's already, as part of ROS2 control, a differential drive controller, which converts twist messages about how fast the robot should be going in which direction, and turns them into instructions about how to rotate the wheels. Now clearly that system knows nothing about Lego and how to physically rotate a Lego wheel. So the brickpi3 motors package, it contains a hardware interface. What this hardware interface does is it picks up those wheel rotation commands from the ROS2 controlled differential drive controller, and it picks up those wheel rotation, speed rotation commands, and actually sends those commands down to the brickpi3 hardware board to actually physically rotate the wheels as instructed. So I'm actually using a launch file here because there's a couple of nodes involved and it can be a bit tricky to get it right. So I've actually used a launch file for this. Anyway, let's kick that off. Okay, that looks like that's starting, and yeah, that's looking good. And this is Windows running locally on my workstation. And I'm just going to ask it, I've got a joystick plugged into this workstation, I'm going to ask it to listen to pick up the joystick movements and turn them into twist messages to be sent to the robot to drive it. So let's get that up and running. That looks good. Now let's go and have a look at our viz. So all being well, if I was to pick up my joystick, which I'm doing now, let's get these images back. We should be able to move Charlie around. There we go. Let's make him a hello Charlie. I think what I'll do is I'll just drive him up towards one of the walls and just illustrate this range sensor. Let's go a bit forward and let's go round. Let's take him up. Oh, let's get more. Bit further over, Charlie. We could just go around. So if you were to look in the window with the axis here, so the length indicates that looks like it's about half a square, which 1 square corresponds to 1 meter, so it's fairly close to the wall. So if we drive further back, we should see that sensor lengthening. You can see that length, that should be generally lengthening. So there he is, it's going back, and if we go further forwards it should shorten. And if we rotate, you should see the sensor rotating around with it to indicate the direction in which the sensor is pointing. So it clearly thinks it's a long way away. One observation, something to note, is that you will, if you can see here, if I'm pointing, I'm going to try pointing exactly towards the wall. That range sensor doesn't seem to align completely with the red. I've spent quite a bit of time playing with this, work out what the reason for that is. I've got a number of transforms set up previously, which provide these orientation mappings. So in principle, that would line up with that, but it's not entirely consistent. I've been playing with this. I think it's to do with my magnetic field in my flat doesn't appear to be completely uniform, and I'm blaming the radiator here. I think it may be distorting that field a little bit. See if I go back. Let's go back. Will probably line up more nicely, and that does appear to be the case. Anyway, something to be careful of. I think I've demonstrated everything that I wanted to do now in this video. So I'd like to thank Charlie and for helping, and you for watching and listening. I hope you enjoyed this. So, well, thank you.